Number one, unit circle basics. On the unit circle, a point angle theta has coordinates cosine and sine. This point lies on a circle with radius 1 centered at the origin. Number 2, sine and cosine as perpendicular. The vectors cosine theta 0 and 0 sine theta are orthogonal, perpendicular, and standard basis because cosine theta times 0 plus 0 times sine theta equals 0. 3. Secant and cosecant as perpendicular. Secant is the length from the origin along the x-axis to the point where the terminal side intersects the vertical line x equals 1 over cosine theta. Cosecant is the same, but along the y-axis intersecting y equals 1 over sine theta. These vectors are again oriented along perpendicular axes, so geometrically they are perpendicular. Tangent and cotangent, same plane, not perpendicular. This where it gets interesting. Tangent equals sine over cosine. It represents a slope. Cotangent equals cosine over sine, also a slope, but reciprocal. Both describe lines tangent to the unit circle or slopes of lines from the origin to a point on the circle. Add theta equals pi over 4. Both tangent and cotangent equal 1, so they lie along the same line as x equals y, hence not perpendicular. Why not perpendicular? Because neither vector is orthogonal to the other in space. Both are describing a direction or ratio of change, a slope, not position vectors on orthogonal axes like sine, cosine, or secant, cosecant. Summary. Sine and cosine are perpendicular because they align with x and y components of the unit circle point. Secant and cosecant perpendicular in orientation because they extend along the x and y axes scaled by reciprocal trig functions. Tangent and cotangent describe slopes. They lie on the same conceptual plane because they are secular ratios, not vector directions on perpendicular axes. Would you like a sketch or animation style breakdown to visualize better?